Welcome. Let us work out this question on vectors. OABC is a trapezium in which OA is equals to A and AB is equals to B. AB is parallel to OC with 2AB is equals to OC. T is a point on OC produced so that OC ratio CT is equals to 2:1. At this one is AT and BC intersect at X, so that BX is equals to HBC and AX is equals to KAT. So there's the diagram. The questions: A, express the following in terms of A and B. Roman 1 OB, Roman 2 BC. Part B, express CX in terms of A, B and H. In part C, express CX in terms of A, B and K. And then part D, hence calculate the values of H and K. So those are the questions. The first thing you're going to do is to input the important values in this diagram to enable us to work out properly. So the first one, OA we are given is A, so it's good to indicate the direction, that is the direction. Then AB is equals to B, AB is parallel to OC given. Then something else we are supposed to note is this, this 2AB is equals to OC. So that one, we have 2AB is equals to OC. Now given that AB is B, therefore OC will be given by 2B. So it's good to indicate, so OC here we have 2B. Then the next one is this ratio OCCT. So there's this ratio here OCCT, which is 2:1, very important. So if we are aware that OC is equals to 2B, given that this ratio is 2:1, if OC is 2B, then this one will be B. The next thing we're supposed to note, we have these, we are going to use it somewhere below the questions that follow. So those are very important. Now let's go to the questions. Part A, express the following in terms of A and B. So part A, we have Roman 1 OB. Now OB is here, so to get to OB is from O to B, we are going to follow this route OA plus AB, OA plus AB. OA is A plus AB is B. So that one is as simple as that. So we go to the second part. The second part is BC. So from the diagram, to move from B to C, we are going to follow this route BA plus AO plus OC. So BA plus AO plus OC. So BA, note that BA, we are moving in the opposite direction, BA, so that will be negative A, plus AO, again AO, we are moving in the opposite direction, that will be negative A, so that again will be negative A. Then OC, OC is given by 2B. So like terms together, so negative A plus 2B, that is B, then minus A. So BC is given by B minus A. Now we go to part B, express CX in terms of, so CX in terms of AB and H. So AB and H. So to express CX in terms of AB and H, we're starting from C, we want to go up to X. So this is the route that you're going to follow, ensuring that you use AB and H. CO plus OA plus AB plus BX. Note that BX, given that BX is equals to HBC. So that is how we're going to get the first expression. So CO plus OA plus AB plus BX. CO is given by CO, we are moving in the opposite direction, so that one will be negative 2B, plus OA is A, plus AB is B, plus BX is given by HBC. So this gives negative 2B plus A plus B plus HBC. We have already calculated BC is here in the previous part, B minus A. So B minus A is BC. So we open this bracket, negative 2B plus A plus B plus HB minus HA. Now what we can do at this stage, we can like the like terms together. You can see we have negative 2B plus B, negative 2B plus B, that will give negative B. So we have A, then negative 2B plus B is negative B, and plus HB minus HA. So we can group together the one that this is A, this one has got A, and then we have the one that has got B. So that and that together, we group them together, and this is how we're going to do it. So we have A minus HA plus the one that has B, this is H, it is minus B plus HB. So factoring out vector A here is common. We shall have 1 minus H multiplied by that by A. Then here we have H minus 1, H minus 1, then this is a B. So this is the first expression. Now let's go to the second expression of CX. The second expression, we're going to use AB and K. AB and K. Note that in this first part we have used this expression BX. So BX is equals to HBC. And then in this one we shall use the other AX is equals to KAX. So the route that you're going to follow in the second one will be CO plus OA plus AX. Let's go to the diagram. CO, so CO plus OA plus is CO plus OA plus AX. That is the second expression. So let us continue. CO is given by negative 2B, OA is given by A, then AX is given by KAT. Let me write this one in smaller terms. So scalar KAT. That is how we get this. So that expression is that given by that AX is equals to KAT. Now let's proceed. So this will give negative 2B plus A plus K. Now AT, let's go to the diagram. AT is given by AO plus OT, and this will give AO is negative A plus OT. From O to T is 2B plus B, which is 3B. So AT therefore is negative A plus 3B. Open the brackets. Get this 2B plus A. This is negative KA plus 3BK. Still go on. The like terms, we can collect the like terms together. We can group them. This is B and this B, and then the one that has got A, this one and this one, we can group them together, and this is what you're going to get: A minus KA, then this plus negative 2B plus 3BK. So this bracket, this is negative 2B. So we factor out for this one, we factor out A, 1 minus K A, plus factor out B here, we get 3K minus 2. So that is the second expression. Now we have expressed Cx in two ways. Now let's go to the last question, which is hence calculate the values of H and K. Part D, calculate the values of H and K. Now to calculate the values of H and K, we shall equate the two expressions of Cx. Since they're expressing the same thing in different ways, but the same thing, we're going to equate these two expressions, and this is how we're going to do it. So we have the first expression, which is 1 minus H. So 1 minus H is A plus H minus 1 B is equals to the second expression, 1 minus K plus B, 3K minus 2. Now, after equating the two expressions, we can now equate the corresponding terms. Like for example, this one with A, with vector A, we equate it with the one with vector A, and then we can equate the one with vector B with the one with vector B, and this is how you're going to do it. So this one, 1 minus H A is equals to 1 minus K A. Now dividing both sides by A will disappear. We divide both sides by A, we remain with 1 minus H is equals to 1 minus K. If you work out this expression, you notice that H will be equal to K. Now let's go to the one with vector B, and this is H minus 1 B is equals to B 3K minus 2. Now dividing both sides by vector B, you notice that this one will disappear, that one will disappear. If we divide both sides by vector B, we remain with H minus 1 is equals to 3K minus 2. So like terms together. But before we group the like terms together, remember from this that H is equals to K. So if we substitute H with K, we substitute this, so that one with K, so we shall get K minus 1 is equals to 3K minus 2. We have substituted this H with K since H is equals to K. So like terms together, okay, bring this K to one side, then negative 1 take it to the other side, so we get negative 2K is equals to negative 1, and therefore K is equals to a half. Now since H is equals to K, then H should be equal to a half as well. So the two solutions are h is equals to a half and k is equals to a half, and that is how we're supposed to work out that question.
Audio Jungle. There was a reason why God brought the truth to you and called you from the darkness to the light. Within your heart, He saw the longing that you had to search for Him and practice what is right. You promised Him